It's so small.
I don't
know.
Like selling.
Oh, wait, yeah, that's right.
Yeah.
I don't literally all of this stuff.
I feel like
And then.
Okay.
Yeah, that's awesome.
Anyway, so, I think I haven't worked. I talked to the people who came on yesterday and on Tuesday, but I think I have it worked. So we'll have class today, tomorrow, Monday. Then we'll have something on Wednesday. I don't know what yet, but we'll do something on Wednesday, Thursday, Friday next week. But I think if we do those this week, those two, whatever you want to call it, next week and a half, then we'll have our last test the Monday. After that, whatever that is, the 10th, I think, May 10th. Is that right? Yeah, May 10th. And then, or May 11th. I mean, we can decide that a little later. And then we'll have our exam after that. So that means you won't have to come back twice, which would be fantastic. So, as far as the exam is concerned, it doesn't matter to me. Originally, I was thinking like do the exam. I think originally I was thinking have the test on May 11th, that Tuesday, just to give you an extra day where you could come in and ask for help for that last test. So that's what I was thinking, is the Tuesday of the last test, and then Thursday for the exam. That's what I was originally thinking. But the folks that were here the past couple of days, some of them were like, I would rather have the exam like the week after, like on that Monday, just to give me more time to study for it, which is fine with me. At this point, I probably would have it ready on Thursday, and you would just have to take it sometime between that Thursday and when you graduate, I guess. I mean, so I don't know that we have to set it where you all take it necessarily at the same time. So that way we can be more flexible towards your all's schedules. So if you're a junior, it doesn't matter. Like you just questions about that? How do you feel about that? Is that a good thing or a bad thing? Miguel, I found out the answer to your question about Ohio State and transferring the credit. So, when you guys are done here, there's some steps that you're going to have to go through to get this class transferred to your whatever school that you go to. And these are steps that you will have to do. Like, no one's going to do this for you. And I would want to hit you upside the head if you end up going to school next year, to college, and you're sitting in a Calc 1 class that you don't need to be sitting in because you didn't do what you had to do. Because you're wasting money if you do that. Unless you absolutely just want to retake it for funsies. I mean, yeah, go ahead and do it. But for many of you, you need those credits and you're done with math and you might not ever take any more math the rest of your life. Some of you might have more than enough math. But you're going to have to, probably sometime over the summer, go to Wright State's website, get an official transcript sent to your school, and have that transcript evaluated so that you can get the transfer credit. I made a video last spring for kids, because normally we do this in class. I would show everybody how to do that. But I made a video last spring from home that I might just share with you guys, because the process is still the same, for you to go about doing that. Most of the time, when you transfer a credit to another university, your grade does not transfer, just the credit. Adele asked about Ohio State. Ohio State, your grade transfers, but it doesn't affect your GPA. So it just shows up on your transcript, but it's not calculated into your GPA. Does that make sense? So I mean, you want it to be a decent enough grade, but it's not going to affect your GPA. Which, Adele, that's not, you're not, I mean, you have nothing for it. I texted Ava Cooperman yesterday and asked her, hey, some people want to know about this. She gave me the tea. So, yeah, and I would say it's possible. I could text some kids at Miami to find out what they do. I wouldn't be surprised if most of the state institutions in Ohio operated the same way, like where the grade comes with you on your transcript, but it doesn't calculate into the GPA. So that's kind of like what Fairmont does for your weighted GPA. Classes that you don't take at Fairmont don't calculate into your weighted GPA if you come from another school. Now, if you take TCP classes, those count in, but if you come from another school. So, all right, questions on all that? You feel sad, scared? Tomorrow, you're going to have a quiz on finding radiuses of convergence. So that'll be when we first come tomorrow. So like the homework that you did past couple days. Step number 25, which I did figure out, by the way. I think we did it yesterday. Although when I was working it out, I got stuck on something. And I took off myself. But that won't be on there. All right. Well, you guys ready to rock and roll here? So what we're doing now is like we're switching over. Like you understand like what a power series is, right? And there are certain values of x for which these power series converge. But now we're going to get into this idea of representing functions that you know and love as power series. Maybe you don't love them, you're just familiar with them. Okay? But we're going to represent functions as power series, all right? The way I have sort of evolved into packaging this content for people is that you really can kind of summarize it into, if you want to build a power series for a function, there are basically three ways to do it. Okay, you can do what I call build it from scratch. You can build it like a new series from one that you already know, which I call the BANFO method. BANFO, build a new from old. Or you can use a formula. Okay? We're going to learn the formula next week. Today, we're going to look at like building it from scratch and then building new from old. All right? As far as building from scratch is concerned, we're going to do this together. And I might have you do it once on your own. But I'm not going to ever test you on building a power series from scratch because it's kind of clunky and cumbersome. Okay? But I think it's important for us to kind of experience it once or twice. Just because you're going to say, oh, that's where the factorials come from, or things will just start to click. So we're going to right now fix this microphone, and then we're going to build a series for sine of x. Okay? We're going to build a series for sine of x, and then we'll use that series to build other series that involve sine. Okay, you'll see what I'm saying in a second. All right, so we're going to use this to build a series or power series for sine of x from scratch. Okay? So this is what we're going to do right now. And I've got a paper that's going to sort of guide us through some of this once we get this done. All right, so here's what we're going to do. What up? So here's what we're going to do. I'm going to assume that there's some series, and I'm going to call it P of x, okay? And I'm going to say it's C0 plus C1x to the first plus C2x squared plus C3x to the cubed plus C4 x to the fourth plus C5 x to the fifth, and so on. I'm going to assume there's something out there that looks like that is sine of x. Okay? That's what we're going to assume. All right? And I just got to figure out what all these C values are, what these coefficients are. All right? So over here, I'm going to write sine of x. Okay? And so what we're going to do is we're going to pick a value of x to center this around. We're going to pick a value of x to build this on. Okay? And then what we're going to do is take the derivatives of sine and the derivatives of that polynomial and set things equal to each other. Okay? So a good place to build this about, what's a nice x value where sine has good results, like nice numbers? 0 or pi over 2 would be the two big ones, right? Like, because the sine of 0 is 0, and the cosine and the sine of pi over 2 is 1, right? So we're going to choose 0. Okay, so I'm going to choose x equals 0 to build this around. And so here's how it works. All I'm going to do is I'm going to say, okay, well, at x equals 0, what's p of 0? Like, what happens if I plug in 0 into all of these x's? What do I get? I get C0 plus a bunch of zeros, right? So I just get C0. All right? So over here, what happens if I plug 0 into sine? What do I get? 0. Okay? So here's the deal. If these two things are going to be the same, then this guy right here has to equal this guy right here. So I'm going to say C0 has to equal 0. Because the polynomial at 0 is going to have to equal the sine at 0. Right? Make sense? So I'm going to put a box around this because we just found our first coefficient. All right? Okay. So now, our next step here, it's really nice when we just have a constant dangling out here. So I'm going to take the derivative of p. So what's p prime of x? Well, what's the derivative of this? 0. What's the derivative of this term? C1. What's the derivative of this term? 2c2, x to the 1. What's the derivative of this term? 3c3, x squared. What's the derivative of this term? 4c4, x cubed. And then 5c5, x to the fourth. And then, I mean, obviously we could keep doing this all day, but we've got to pray that there's a pattern or something, right? Okay, so now I'm going to over here, I'm going to take the derivative of sine. So what's the first derivative of sine? Cosine. Okay, and I'm going to plug in 0 into this cosine. What do I get when I plug 0 into that cosine? 1. Over here, what happens if I plug 0 into p prime? What do I get? C1 plus 0, 0, 0, 0, 0, 0, 0, 0, right? So let's just get C1. But p prime of 0 has to equal f prime of 0. So what's C1 equal? 1. Okay, we're going to put a box around that. Okay? All right, let's do p double prime. What's the derivative of this term? 0. What's the derivative of this term? 2c2. Or 2c2. It's just more fun to say 2c2. What's the derivative of the next term? 6c3x. But I'm going to write 6 as 3 times 2 c3 x to the first. What's the derivative of the next term? 4 times 3 c4 x squared. What's the derivative of the next term? 5 times 4 c5 x cubed. Right? Okay, now over here, so we found the second derivative over here. I guess we got to find the second derivative over here. What's f double prime of x? What's the derivative of cosine? Negative sign. So what's f double prime of 0? Zero. So here's the deal. This guy right here at 0 has got to equal this guy over here at 0. So what's p double prime of 0 over here? What happens if I plug in 0 for x? I get 0, 0, 0. But what do I left with right here? 2c2. So 2c2 has to equal whatever it is over there. So 2c2 has to equal 0. So what's c2? 0. I'm going to put a box around that. Normally when we do this, I do this on 2 boards. So I'm building the polynomial on one board and we're doing the derivatives of the function on the other board. But because we have to have this camera on, like, we can't do that. So we're going to run out of room real fast. But that's okay. All right. So what do we got to do next? What do you think? I mean, we're just going to keep doing what we've been doing. So what's our next step? Triple prime. Good Lord. Okay, what's the derivative of the first term? 0. Derivative of the next term? 3 times 2 c3. Yes? Okay, next term. 4 times 3 times 2 c4 x to the 1. Next term. 5 times 4 times 3 c5 x squared. And then plus yada, yada, yada. I'm just hoping that we see some sort of pattern, like that I don't have to keep doing this, okay? Right now, it's not looking good. I mean, maybe, does anybody see a pattern, what's happening? I mean, if I were to pause right now and say, what are you noticing? Like, what are you noticing? There's a factorial that's being built, for sure, in front of those coefficients, right? Anything else?
I was just thinking maybe like alternate series.
It's in alternating. It's actually going to start alternating right now, because over here, I'm going to put it right here. What's f triple prime of x? Negative cosine. And what's f triple prime of 0? Negative 1. So there's where Maddie's saying, oh, this might alternate. Because I'm going to set this negative 1 equal to, over here, what's p triple prime at 0? It's 3 times 2c3, right? And so 3 times 2c3 has to equal negative 1. So what's c3? Negative 1 over, and how about we just call that 3 factorial? Because that's what it is. Okay? Okay, what's next? I'm going to stick it right here. We're going to do the fourth derivative of p. Oh my Lord. Okay? Now how do we even represent a fourth derivative? Well, we stop using tick marks and we just put 4. like that, okay? Otherwise, we'd be ticking all day. So what's the fourth derivative of our polynomial? 0, and then we got this, 4 times 3 times 2, C4, plus 5 times 4 times 3 times 2, C5x. And then I'm going to still put the plus yada, yada, yada. Okay. Let's go ahead and find the fourth derivative of p at 0. Since we're right here, what's the fourth derivative of p at 0? 4, well, p. I think I did them out of order. I've been going back and forth and then putting 0 in. But if I do plug in 0 here, I get 3, 2, C4, right? So over here, what's the fourth derivative of sine? We're back to sine again, right? And what's the fourth derivative at 0? 0. So I'm going to set this 4 times 3 times 2, C4 equal to 0. What's C4 have to equal? 0. Okay. Well, hopefully we see the pattern after the next one because we don't have any more terms. What's the fifth derivative of p? Five times 4 times 3 times 2? C5? And then plus a bunch of other stuff that we're not writing down, but it has x's in it, right? What's the fifth derivative of sine? So what's the fifth derivative at 0? 1. So that means this, the fifth derivative of p at 0, which we know to be 5 times 4 times 3 times 2, C5, has to equal 1. So what does C5 equal? 1 over 5 factorial. Okay? So now what I want you guys to do, like on your paper in a clean space, assemble all the pieces. Like what you have right now is sort of all the ingredients like dumped out on the table, and you're going to put them together to make the cake. So assemble all the pieces and write out what this polynomial will be. Okay? While I erase the board, because I'm going to need. I got to erase the board. I don't have a place to put it. I guess I could stick it right here. So what's p of x going to be? Like, you want to do it together? Yeah, well, I got a lot of hot air coming out of my mouth. So we're going to build it. Okay, so ready? So all we're going to do is just take this piece, this piece, this piece, this piece, this piece, and this piece, and put them together up here. So what's C0? 0. Plus, what's C1? 1x. Plus, what's C2? 0. 0x squared. Plus, what's C3? Negative 1 over 3 factorial x cubed. Plus, what's C4? 0. X to the fourth. Plus, C5. 1 over 5 factorial x to the fifth. Okay, now, do you see the pattern? What's the next term?
Minus 1 over 7.
Okay, well, it depends on what, are we saying the next non-zero term or the next term in general? Because the next term would be 0. It would be plus 0 x to the 6th. Then what? Then what? positive 1 over 9 x to the 9th. 1 over 9 factorial, sorry, x to the 9th. Okay? So what have we done here? We have built the series for sine of x from scratch. So like if you think back to that first day when we started playing around with this and I showed you those graphs, that was the series I was showing you. That's where it came from, was this. We just built it from scratch. We said, okay, we're going to assume it is a series, and we're just going to start setting these derivatives equal to each other. Okay? So let's put all this together. This is where you get scared. So sine of x, we now know, can be written this way. 1x minus 1 over 3 factorial x cubed plus 1 over 5 factorial x to the 5th minus 1 over 7 factorial x to the 7th plus 1 over 9 factorial x to the 9th, and so forth. It's only sine of x if you have all the terms. It's an approximation of sine of x if you chop it off. Okay? But then we're going to put this in sigma form because we need to recognize what it looks like in sigma form. So it's going to be negative 1 to the n plus 1, since I'm starting at n equals 0. Okay? Now, what do you notice about the powers of x? They're all what? Odd. And what do you notice about the factorials? They're all odd, and they're the same as the power of x, right? So how do we generate all the odd integers when starting at 0? X to the 2n plus 1. And then divide that by 2n plus 1 factorial. Okay? That, my friends, is sine of x. It's crazy. It's crazy to think that sine of x is a polynomial that has an infinite degree. And it's odd. If you remember sine's an odd function, notice how it's odd, polynomials, right? Well, you're going to do it right now, right? Exactly right. But we're going to do it together right now. Man, this is so much fun. It's just 2021. Can't do all the fun stuff. Okay. So we've done the first part of this. You guys said the reason why I didn't give you this because I knew that some of you wouldn't listen when I said don't try to write all this on this one, and some of you would have tried to write it there, and it would have been a lot. Okay. So now you can, if you want, you could probably start doing this on here. It says write the first 3 non-zero terms and the general term. Okay. So here we actually wrote several more than the first 3. 1, 2, 3. I mean, we wrote the first 5 non-zero terms. But the general term of this is that right there, or the sigma form. I mean, you can even write the sigma form, and that tells me that you understand the general term. Okay? And then you actually don't have to write it down, though, kids, because right underneath it says the answer that you got for the question above should be, and then it's all written. Okay? So now we're going to go do what Maddie just sort of was sniffing around at. She used to ask me, I said, oh, those are odds, the sign's odd, right? She said, would the cosines be even? Right? That's a great question. So now what we're going to do is our first example of what I call the Banfo technique. We're going to build the series for cosine from the series for sine. Because we know that the derivative of sine is cosine. So if I take the derivative of this series right here, I should be able to get the series for cosine. Okay? So let's do that. So we're going to say, okay, well, cosine must be, let's start taking derivatives. What's the derivative of this first term? 1. What's the derivative of this term? Well, it's negative 3 over 3 factorial x squared. Yeah? What's the derivative of the next term? 5 over 5 factorial x to the 4th. Oh, I see the evens. What's the derivative of the next one? Negative 7 over 7 factorial x to the 6th. What's the derivative of the next one? Plus 9 over 9 factorial x to the 8th. Plus yada, yada, yada. Okay, but we're going to simplify this. Okay, we're going to simplify this. One quick note. I cannot put cosine of x equals unless I put the plus yada, yada, yada. Right? It's not cosine if I just write that. It's only cosine if I say continue that on. Okay, now how's this simplify? Can we do this in our head? We've done this so many times at this point. What's 3 divided by 3 factorial going to be? Normally it's the other way around. It's 3 factorial over 3. So this is minus 1 over 2 factorial x squared. What do you think the next one is? 1 over 4 factorial x to the 4th minus 1 over 6 factorial x to the 6th plus 1 over 8 factorial x to the 8th. Yada, yada, yada. Okay? And can we put that in sigma form? Well, it's going to be n equals 0 to infinity. The negative 1 to the n plus 1 is still going to hang. But now, you could even, guys, look at this. You could even just take the derivative of this general term. What happens if you take the derivative of this with respect to x? You get negative 1 to the n, because that's not going to change. Sorry, n plus 1. You get negative 1 to the n plus 1, then you get exponent comes down front. Subtract 1 from the exponent. What's 2n plus 1 minus 1? X to the 2n over 2n plus 1 factorial. And guess how that simplifies? Like that. So when I go down here and put it in sigma form, that's what we get. Okay. So now we got a series for cosine. All right. So now if we flip this paper over, okay, if we flip this paper over, it says write out the power series expansions for these functions: sine of x, cosine of x, and e to the x. Okay, we haven't done e to the x. I'm going to give it to you here in a second. Okay, now I'm not going to, you can rewrite those on your own, but we don't need to write them again. So let's do e to the x real fast. I'm just going to tell you what e to the x is. Is that okay? We're not going to build it from scratch. I'm just going to tell it to you. It's like someone here, they just handed you a new house. Here you go. You have to do nothing. All right? So e to the x is this. It's 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed. We've seen this one before. 1 over 4 factorial x to the 4th, yada, yada, yada. Can you put that in sigma form? What do you think it is? What do you notice about the exponents? They're all integers, right? And they're all there. So it's x to the n over n factorial. Okay? And that works because 0 factorial is 1. I keep telling you I'm going to show you why that is, and there's never the opportunity time to do it. Right? The reason why 0 factorial is 1 is if you think how we've been simplifying factorials, like 5 factorial divided by 4 factorial is 5, right? 3 factorial divided by 2 factorial is 3. 2 factorial divided by 1 factorial is 2. 1 factorial divided by 0 factorial has to be 1. It can't be anything else, otherwise it won't work. So now we've got a series for sine, cosine, and tangent. No, sine, cosine, that's how often do you say those three together? We have a series for sine, cosine, and e to the x. Okay? So how do you think we can build a series for a new function? I think the first one on there is what? Sine of x squared? How do we do that? Do you want to do it from scratch? No. No way. You don't want to do that from scratch. That's a hot mess. You want to do it from the series for sine. So that's x minus 1 over 3 factorial x cubed plus 1 over 5 factorial x to the 5th minus 1 over 7 factorial x to the 7th, blah, 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 right? So what's sine of x squared going to be? Guess what you do? Tells you there. What do? Just plug in x squared in for x. So it'll be x squared minus 1 over 3 factorial x squared cubed plus 1 over 5 factorial x squared to the 5th minus 1 over 7 factorial x squared to the 7th, yada, yada, yada. And then if we want to do it in sigma form, everything stays the same as before, except now it's going to be x squared to the 2n plus 1 over 2n plus 1 factorial. Now, we could use our properties of exponents here if you wanted to simplify that to negative 1 to the n. When you have power of a power, you multiply the exponents, right? So 2 times 2n plus 1 would be x to the 4n plus 2 over 2n plus 1 factorial. So like, if you think about this is squared to the 6th to the 10th. What's this one? 14th. That's sine of x squared. Okay, what do you think x e to the x is? What do you think x e to the x is? How are you going to do that one? Multiply each term by x. Okay? Here, I'm going to give you this. I think you're going to be able to do this. Get as much of it as you can. I'm gonna start being like Miss Templeton. I walked in and talked to my daughter during the first period of class before school started today. There's like 2 minutes before the bell rings. All of her kids are sitting in their seats with their Chromebooks out, and she's already teaching. Like, there's kids out in the hall running around. She's already teaching. She's got those little freshmen with them shit. God, no! Come on, no, I'm not. You're gonna get tested on it. Your last test of the year.
Yeah.
No, we have another test. We got more papers in the past 3 weeks than you did all year.
No, I mean like our road. Keep counting road.
Oh, I don't know. I mean, we just flew.
I know, I did.
Oh, again? It's the 50 minutes. It's the 50 minutes.
Keep running.
I don't want to.
You don't have. You'll sign up. Remember those papers that I passed you out at the beginning of the semester and you signed up? You'll sign one of those.
But I don't have to like get on my website and like.
No, because you're already in.
Oh. And then I haven't figured out radius.
Yeah.
So for each one, do we need to like check it to see if it equals?
You mean check the endpoints?
Yeah.
You will not have to do that tomorrow. Because I don't feel like.
Okay, because like none of them had, I didn't check any of them, but we checked this one together, so like.
Yeah.
I just didn't know.
I didn't realize for the first, like, it was like 13 to 19, they actually gave you the intervals.
Yeah, they did.
And I didn't see that in the directions. I thought it was just find the radius. So I'm not gonna have you do that on a quiz tomorrow because we didn't do enough of that.
Yeah.
Can I go see,
Yeah. Yeah, I think he came in here while I was teaching last period to talk to some of those kids. Okay. Yeah, we didn't do enough of that. Like I feel like we need to do more of that part of this. For the quiz. So tomorrow you just have to find the radius.
Oh, it's just radius?
Yeah. You won't even have to find the interval.
Billy, are you taking Calc2 next year?
hopefully.
Okay. I just wonder like who's gonna be that class.
Yeah, I'm fine.
What you need to do is you need to convince your friend Emmy.
Emmy, she just doesn't want to go into math at all. So like, she's just gonna say 8 and 7. I know she's.
Billy. Oh, yeah. Sam, is that, oh, Samuel, my bad. Your hoodie, what's that from? That's what I thought.
Watch the game now.
Oh. No, no.
I'm confused about my kid.
Oh, I figured that part. What?
Like,
I'm confused about my GDP.
No, I didn't get that either.
Is he good or bad? I'm so confused.
I don't know.
Wait, is that the main character? Or is that like the other one?
Are you ready over?
Great.
wait,
Why
is
is
that
so
the one
hard
where
to
they
try?
burn all the books?
You just sit here all day. Like I,
The
like,
longest one I sat learning is that's why I have 2,000 hours recorded on Twitter.
Bro, Prairie is so fun.
The first big year, I couldn't do anything else. Like, didn't believe it was my friend for me. But I just,
You know, people decide to teach what you give them pencils. The teacher is free. I don't know more. You decide which one you want.
Well, if you have fifth grade or sixth grade, I finished all my math entire quarter early. I did the whole class.
Didn't you just like do every single problem?
Yeah, we did. I did go in there and I had 20 now, because I have it for a week.
I really-
I love literature.
Nothing.
No, it was I remember, like, in one class, I had all the work in the book.
Like I like her. You know who I didn't like? Miss Becker.
I loved Miss
That's
Becker
because she loved
because she
me.
loved me.
You had Miss Lamb? No. Okay.
Wait, who was our seventh grade? Like when we were in sixth grade.
When we were in sixth grade.
Who was our sixth grade? Gogan, that's right. Yes.
Oh, you were.
And I was in, when you guys were in fifth grade?
Yes.
Oh yeah, because I skipped.
You never got kids watching that thing?
Yeah, I had Gogan for a week, and then he was like, I'm gonna move you up.
I skipped.
My car is driving funky now.
I'm not gonna-
Your car is?
Sorry.
Yep.
Uh-oh.
So I think I'm gonna have to go get it looked at.
Yeah.
It's driving like all jerky now, and it starts up really slow.
Driving jerky, though, sounds like a transmission issue.
Oh, I don't know. It's a whole mess. My car like broke down yesterday, and I like 2008 Pilot. It like turned on. And then I
Okay.
couldn't move my wheel, and then
So-
I pressed the gas. It was a hot mess.
Here's what we're gonna do. So I talked about this yesterday to people, but I think I have it figured out that you're only gonna, those of you that are seniors are only gonna have to come back after next Friday twice. Once to take your last test and once to take your exam. So we won't have to have classes. The last test, it would be nice if we did it all together, but then the exam, I can be pretty flexible. I'll have the exam ready on Thursday, the week after your last day, which is like 13th maybe. And you can take it anytime from Thursday on, except I won't be here on that Friday. So, anytime during that time, yeah. I mean, you can.
Let's say like during
I mean,
class.
we gotta block off some time for you to do it for 2 hours for the exam. So like, we probably need to figure that out.
I can skip stats.
We won't be able to. Yeah, you could have to be a P test.
Yeah. Because Brewer said as soon as we were basically out of those stuff.
So we'll figure all that out when we get there. So what we're going to do today and over the next few weeks is we spent this time like learning about power series and finding radiuses of convergence and what it means for a power series to converge. Now we're going to actually look at functions that we're familiar with and their power series representations. Okay, representing the function sine of x, for example, as a power series. I've sort of kind of come to package this, you know, in a way such that there are basically three ways to build a power series for a function. You can build it from scratch, where you just, which is what we're going to do. I call it building it from scratch. You can build it once you know series for other functions. You can build it from series that you know. I call that the BANFO technique, build a new from old, BANFO. And then you can also use a formula. Okay, and we'll learn the formula at the end of next week. Okay? So today we're going to start the process of building one from scratch, and then using that one to build other ones. Okay, the BANFO technique. All right, so everybody cool on that? So we're going to start with sine of x. We're going to build a series for sine of x. This is so fun. So you might want to get out a piece of paper. I mean, we're going to take these notes, right? It's kind of clunky. Building from scratch is not, it's very clunky, tedious. But it's good for us to have an experience in building from scratch, so then you can see, like, oh, that's where factorial comes from. That's where, oh, yeah, make some connections. All right? So we're going to build a series for sine of x. Okay. So what we're going to do is I'm going to just write this out. I'm going to say P of x, which stands for polynomial. It's going to be C0 plus C1x plus C2x squared plus C3x cubed plus C4 x to the fourth plus C5 x to the fifth, and so forth. That's what a power series looks like, right? Didn't we use that kind of form for a power series? I think we used C's, didn't we? Or did we use A's? Did we use C's? In some books we use A's, so C's is better because it's coefficient. That makes sense. Okay? So we're going to assume that sine of x is one of these. Okay? So over here, I'm going to write out sine of x. All right? And now we need to think of a value of x upon which to build this. A value of x upon which to center this. Okay? And so we want to think of a value of x where sine has very favorable outcomes. Like, what's the value of x where sine comes out real nice? 0? Pi over 2 also, right? I mean, pi over 2 and sine's 1. 0 and 1 are nice numbers to work with. Okay? We're going to use 0, though. Okay? So we're going to build this about x equals 0. Okay? So it's real simple. We're going to do this, okay, by just looking at this function, this polynomial here, and the sine function, and their various derivatives at 0. Okay? So our first step is going to be, okay, if I plug in 0 into that polynomial, what do I get? If I plug 0 into that whole big mess, what are you going to get? You plug in 0 for x, what are you going to get? That's not a hard question. C0. Very nice, okay? Over here, What do I get if I plug 0 into sine? 0, right? Now here's the thing, friends. If these two things are going to be equal, then those two things that we just got have to equal each other. Okay? So P of 0 is going to have to equal F of 0. So over here I'm going to say then C0 is going to have to equal 0. So I'm going to put a box around that because I just found my first coefficient. I just found my first C value. All right? Next one. Let's find P prime of X. He's running out. All right, what's P prime? What's the derivative of C0? 0. What's the derivative of C1 times X? C1. What's the derivative of C2x squared? 2C2 x to the first. Plus, what's the derivative of C3x cubed? 3C3 x squared. Plus, what's the derivative of C4x to the 4? 4C4 x cubed. Plus 5C5 x to the 4th. Plus yada, yada, yada. Okay? I mean, this pattern actually continues on forever. We're just not writing all that, right? And we're hoping and praying that we see some sort of pattern in this that we don't have to keep on. Because I don't want to do this all day. No, neither do you, right? Okay, so that's P prime. What's F prime? What's the derivative of sine? Okay, all of you should be answering this, right? This is not. So the derivative of sine is cosine. Okay, so what's F prime of 0? What's cosine of 0? 1. What's P prime of 0? Plug in 0 for X. What are you going to get? C1 plus 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. How about C1? So P prime of 0 is going to have to equal F prime of 0. So 1 has to equal C1. I'm going to put a box around that. All right, let's keep going. What's P double prime? So derivative of C1, 0. Derivative of 2C2x, 2C2. Plus, what's the derivative of the next term? 6C3x to the first, correct? But I'm going to write 6 as 3 times 2 C3 x to the first. Plus, what's the derivative of this term? 4 times 3 C4 x squared. What's the derivative of the next term? 5 times 4 C5 x cubed. Yada, yada, yada. Okay, so is that the second derivative? Okay, what's the second derivative over here? What's F double prime? Negative sine of X. What's F double prime of 0? 0. Okay, I didn't find it. Let's find it over here. What's P double prime of 0? It's 2C2. So here's the deal. This guy at 0 has got to equal this guy at 0. That should be double prime. So 2C2 is going to have to equal 0. So what's C2 equal? What's C2 going to equal? 0. Okay, what's next? What do we got to do now? Triple prime. So what's B triple prime? Derivative of that is 0. Derivative of this is 3 times 2 C3. What's the derivative of the next term? 4 times 3 times 2 C4, x to the first. What's the derivative of the next term? 5 times 4 times 3 C5, x squared, yada, yada, yada. Okay? Let's go ahead and find P triple prime of 0 while we're at it. What's that going to equal? Three times 2 C3. Yeah? Okay. Over here. What's F triple prime of x? So derivative of negative sign is negative cosine of x. What's F triple prime at 0? Negative 1. So F triple prime at 0 is going to have to equal P triple prime at 0. So 3 times 2 C3 is going to have to equal negative 1. What's C3? Negative 1 over 3 times 2. Okay? Let's do another one. So what's our next derivative? The fourth, right? Now I will be honest, so normally when we do this, I do this on 2 separate boards. So all the P stuff's on one board, all the F stuff's on another board. But I have to keep all this on one board for the camera. So it's kind of getting funky, right? So I'm going to stick the fourth derivative of P right here. Now we don't use tick marks once you get past 3. You just use the number 4. What's the fourth derivative of P? Four times 3 times 2 C4 plus 5 times 4 times 3 times 2 C5 x to the first. Plus yada, yada, yada. Okay, what's the fourth derivative at 0? 4 times 3 times 2 C4. What's the fourth derivative of F? Okay, so we're back to sine. What's the fourth derivative at 0? 0. So 4 times 3 times 2 C4 has to equal 0. What's C4? 0. Put a box around that. Okay, I'm going to pause for a second. So we're going to pause. I'm going to ask you, what are you seeing? Okay, what are we doing? Okay, because if you don't know what we're doing and you're just writing stuff on the down, you're wasting time. Like, don't even bother writing it down. What are we doing? What's the goal here? We're figuring out the C's, right? What are you seeing? What are you seeing? What are you noticing? There's nothing wrong that you notice. Whatever you notice is going to be correct. Billy, what are you noticing? All the evens are 0 so far. What else are you seeing?
The coefficients are being multiplied by what's approaching a factorial.
Right, there you see a factorial sorting developing. Okay? Anything else that you're noticing? Someone saw this last period, and I don't know that I would have saw it.
The terms are flip-flopping positive negative.
Yeah. I mean, they picked up on that, just that C1 was positive 1 and then C3 was negative. So they thought there's an alternating here. Okay? All right. Let's do another one. What's our 5th polynomial? 5th derivative. What's that going to be? 5 times 4 times 3 times 2 times 1, right? C5 plus yada, yada, yada. I mean, there are other terms out there, but I'm hoping I see a pattern. All right, what's the 5th derivative of sine? Cosine. So what's the 5th derivative at 0? Well, we know it's 1. So this has to equal this at 0, right? And what is the 5th derivative of p at 0? We didn't write it down, but it's 5 times 4 times 3 times 2, C5. So 5 times 4 times 3 times 2, C5 has to equal 1. So what is C5? C5 is 1 over 5 times 4 times 3 times 2 times 1. Or I don't need the times 1, I guess. I'll put a box around that. So do you think now you could start assembling this? It's like I've just dumped all the ingredients of a cake out onto a table. Can you start to put the cake together? Okay? Can you start to say, oh, sine of x is starting to look like, well, let's just plug them in. 0 plus C1. 1x plus C2. 0x squared plus C3. Where was it? Right here. 1 over 3 times, or negative 1 over 3 times 2. How about we write that as negative 1 over 3 factorial x cubed plus 0 x to the 4th plus C5 1 over 5 factorial x to the 5th plus, what's the next one? 0 x to the 6th plus, what's the next one? Minus 1 over 7 factorial x to the 7th, and so forth. So what are we noticing? It's kind of what we just said, right? It's even or odd powers, and they alternate in sign. And what do you notice about the coefficients, the c values, and the exponents? What do you notice? Same thing, right? So my friends, let's put all this really together and say, okay, I think we just built a series for sine of x from scratch. So sine of x is going to equal, now I'm not going to write the 0 terms in, x minus 1 over 3 factorial x cubed plus 1 over 5 factorial x to the 5th minus 1 over 7 factorial x to the 7th plus 1 over 9 factorial x to the 9th, and so forth. Okay? Now, it's not sine of x. I can't put equals unless I put and so forth here. Okay? Because if I don't put the dot, 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 sine of x is not just that 9th degree polynomial. It's not sine of x until you have all infinite numbers of terms. Now, it's a darn good approximation of sine of x, as you guys saw back a month ago when you first got exposed to this. Didn't we do that? Could we put this in sigma form? Let's put it in sigma form. Well, we noticed that it's alternating, so we got to have some way to make it alternate. So the way I'm going to make it alternate is I'm going to use the power of -1. And since I'm starting with n equals 0, I'm going to make it -1 to the n plus 1. That ensures that. What?
Yeah, shouldn't it be just the negative 1 to the end? Because you want to start with positive. And then 1 to start with negative.
It is, you're right. I did that last period and I don't even think I realized that. Son of a biscuit. I cannot believe I did that. Oh my gosh. What am I going to do?
I think you'll be okay.
Oh. I think I did that. Okay, so how am I going to... What do you notice about those exponents? They're all odd, right? So how do I make odd numbers when I start at 0? 2n plus 1. Divided by what? These got to match. 2n plus 1 factorial. Oh, I'm so angry. Ah. Can't get over it. I can't get over it. I'm not going to be able to let it go. I'm going to be thinking about this all day. All right. So what we have here is a power series representation of sine of x. That is the sine function. It's another way of looking at it, right? So how do you think we could get the cosine function? How do you think we could find a power series for the cosine function? And this will be our first example of BANFO. Build a new from an old. Because you know how sine and cosine are related, right? How are sine and cosine related? Cosine's the derivative of sine, right? Okay, don't do anything yet. The quiz tomorrow is over just finding radius of convergence. It's not this. You should know that I'm not going to give you a quiz over something that I'm teaching you today, tomorrow. That has never happened in my life. Come on. Unless I said, okay, I need you to take this home and memorize it. Which, that's, I mean, every now and then, that might happen. Billy. Okay, so what we just did here, so go to the side of this, it says use the building from scratch technique. Okay, we just did part A, or the first thing. Build a series for sine of x. Write the first 3 non-zero terms in the general term. Okay, well, that's written on the board. In fact, we've got the first 1, 2, 3, 4, 5 non-zero terms in the general, and this is the general term, right? Now, the reason why I didn't give you this paper ahead of time because I knew that somebody wouldn't listen when I said, don't try to write this all on this paper, and you would have tried to do everything that we just did in this little tiny spot. Somebody would have tried to. Okay. Who? Gavin would have done it? No. Oh. Well, who in here tried tried to do all those when we did the convergence tests, when I handed out those worksheets, I said, don't try to do all these on this paper. And I come in and see everybody's all this work.
Billy did it.
Okay.
He's trying to blame it on me.
And then you don't even need to write it down again because it says right here, the answer that you should have gotten to the question above is, there it is. There's the general term. Okay, and notice it's typed correctly there. -1 to the n, not -1 to the n plus 1. Okay? So now, my friends, we're going to BANFO here. Build a new from old. That's what BANFO stands for. Build a new from old. B-A-N-F-O. Maggie Burning and shoot. Spangler. Which one of the Spangler boys? Nick. They came up with the BANFO technique. That's why I wrote it up there. They wanted, because they came up with that acronym, BANFO. So they said, write that up there. So here we go. Cosine is the derivative of sine, yes? So if I take the derivative of these terms, what do I get for this? 0 minus derivative of this term here, 3 over 3 factorial x squared. Derivative of this term here, plus, wait a minute, hold the phone here. The derivative of this term right here is not 0. What's the derivative of this term right here? 1. Plus 5 over 5 factorial x to the 4th minus 7 over 7 factorial x to the 6th plus 9 over 9 factorial x to the 8th, yada, yada, yada. Now, can you simplify that? 3 over 3 factorial. I hope by now we can do this simplifying in our head. Now, you're normally used to doing it reversed. 3 factorial over 3. Like you're used to reversing that and simplifying it. But how is this going to simplify? 1 over 2 factorial x squared. How's this one going to simplify? 1 over 4 factorial x to the 4th minus 1 over 6 factorial x to the 6th plus 1 over 8 factorial x to the 8th, yada, yada, yada. How about that? Sine's an odd function. You learned the even and odd identities for sine and cosine back in the pre-calc days. Isn't it ironic that sine's an odd polynomial? Cosine's an even function, and cosine's an even polynomial. Can we stigmatize this? This is really cool. Look up here. Okay? You actually don't have to think of what the pattern is here and try to put it in terms of n. You could just go right here and take the derivative of this. Okay? The only thing you got to worry about is x, right? Let me write it like this. This will make more sense. The derivative of this so the only thing we got to worry about is the x. -1 to the n. What happens to the power on x? What happens to it? Comes down front. And what do you do with the power next? 2n plus 1, you subtract 1, right? That's going to be 2n divided by 2n plus 1 factorial. But how does 2n plus 1 over 2n plus 1 factorial simplify? 2n factorial, right? So there's our series for cosine of x. Sweet. Okay? Now if you flip that paper over, we're going to work with sine, cosine, and e to the x first. Okay? Now we know sine, and we know cosine. I'm going to just tell you the series for e to the x. Okay? So we're not building it, I'm just handing it to you. It's like someone just gave you the keys to a new house. Here you go. Okay, we're not going to go through the work of building it, just because of time's sake. So e to the x. Here's the series for e to the x. 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed plus 1 over 4 factorial x to the 4th plus 1 over 5 factorial x to the 5th. Yada, yada, yada. Can you stigmatize that? How can we write that in sigma form? What do you think, Nicole? Yep. No negative ones that we got to worry about. Exactly. Okay? That's e to the x. So now that we know all three of these, we can do combinations. Okay? We can build series for other forms of these functions. Compositions of these functions. Okay? For example, the first one on that thing says sine of x squared. Is that the one okay, so yeah, let's do sine of x squared. Well, all you have to do is take the series for sine of x and plug in x squared. So here we go, ready? Here's my series for sine of x. You've probably written down somewhere else, but sine of x is x, so x squared minus 1 over 3 factorial x squared cubed plus 1 over 5 factorial x squared to the 5th minus 1 over 7 factorial x squared to the 7th. How many terms did it ask you to write down there? Several. Several. Okay, that's several. Now we could simplify this, right? That's x squared minus 1 over 3 factorial x to the 6th plus 1 over 5 factorial x to the 10th minus 1 over 7 factorial x to the 14th. Yeah? But what if I asked you to write this in sigma form? Okay? If I ask you to write this in sigma form, don't go chasing the terms of this series and trying to figure out the pattern. Go back to the sigma form for sine and do the same thing that we just did. The sigma for sine was -1 to the n, but plug in x squared here. X squared raised to the 2n plus 1 over 2n plus 1 factorial. And then simplify it. So much easier than trying to figure out a pattern. Nobody wants to figure out a pattern. What's the power on x going to be? Now you got to know some algebra. You got to be able to multiply those exponents. 4n plus 2. Over 2n plus 1 factorial. Beautiful. So that's sine of x squared. Oh my gosh, this is so fun. So complex. What's the next one? X e to the x. So what are we going to do? Take e to the x and multiply it by x. What's the first term going to be? X plus. What's next? X squared. What's next? 1/2 factorial x cubed. What's next? 1/3 factorial x to the 4th. 1/4 factorial x to the 5th. Yada, yada, yada. Oh, okay. How are we going to sigmatize this? Don't go chasing the terms and looking for a pattern. Just do x times x to the n over n factorial, and then simplify that. X to the n plus a 1 over n factorial. I don't know what happened there, but it's not what I wanted. Oh my gosh, I love power series. This Banfo technique is amazing, right? What does the Banfo tech require? In order for you to be good at the Banfo technique, what do you have to do? What? You got to know the series, right? You got to know the series for sine, cosine, e to the x. We're going to learn about 6 of them. We're going to learn the other 3 tomorrow. Okay? So what your homework is going to be is this tonight. You're going to practice the Banfo technique. You can try cosine of radical x on there if you want. But you also have a e to the radical x here. I'm loving the Banfo. Banfo. Might be Banfo. What? Banfo? Build a new from old. You can build it from scratch. You can build a new from old, or you can use a formula. We haven't learned formula. Building from scratch though sucks.
Is the formula any better?
Formulas. Wait up. All right, my friends. Peace be with you. Have a nice day. I might see some of you at a track meet, because apparently I'm driving to the track meet now. Because they lost the buses. Yeah.
Yeah. I'm driving people too.
Wait, are they still having a traffic today?
Well, that's 50.
It's raining. Doesn't sound like you're talking.
Committing a federal offense just to